In this diagram, we are given to get this diagram in isometric projection. So this is how we are going to have it after the converting it to isometric. We are given the front and the plan. So converting to isometric, we are going to have that. So we started with our horizontal line, then we put our set square after making the points. So our protractor to get angle 30 to the left, 30 to the right, then 90 degrees upward. So this is the basics for us to start the isometric projection. Now, when looking at the diagram, I discovered that the dimensions are a little bit large. So assuming we are drawing more diagrams, so we have to scale it down. So I'm using the scale of 1 to 2. That means all my dimensions from the sketch will be divided by 2. For here is 102. The other part there, the radius is 50. So that's 50 plus 102, that's 152. So total length to the left is 150, total length to the right is 100. When you divide it by 2, that's 76 and 50. So that's what we are going to use. Then upward 100 divided by 2, also that's 15. So I'm going to mark 5 centimeters to my right on the right isoplane, 5 centimeters upward on the vertical axis. Then to the left hand side, total length 7.6 centimeters to the left isoplane. Now at this lower part there, we have 20 length, 20 divided by 2, that's 10. So we mark 10 there to the left isoplane also from the same point. The reason why I'm dividing everything by 2 is because I'm scaling it down. So I get vertical line with my set square, not with your ruler, but so with your ruler and your set square. From 5, from 2, and also from the 7.6 also. So I get a faint vertical axis from each of those points. From 5 at the right, from 1 rather. I'm no more having 2, but I'm having 1 there. From 1 at the left, then from that. Now at this height of 5, I'm going to get both right and left isoplane, which I'm able to do here with my set square, as you can see. Then from the intersection with the 5 there, I get the left isoplane. Then from intersection with that 7.6, making sure my ruler is on the line. Don't forget that. Then I set square to it, so I also get the right isoplane from there too. Now, which means my entire diagram now, at the end of the day, will be just within this box. Everything will be within this box. So we've gotten total length, height, and width. Now, from here we have 12. Half of 12 is 6. So I take 0.6 at this point because I've divided it by 2. I take 0.6. From there, I get a slant line 2. And I extend it. So next, so getting the other part, that slant line that we have there. But first of all, I take the width downwards. That width of that part is 20. Now to do some calculation, 20 in the middle of 20 minus 80 minus 100 minus 20, that's our 80. Now if everything from here down is 80, but first of all, I take 1 and 1 down so that I can get the first line. You know that width there is 20, that's 10. So 1 centimeter downwards. That's what I did there. Now after taking the 1 centimeter down, now remember I said 100 minus total height is this. I cannot use my protractor, even though the angle is given to be 45. I can't use my protractor. I have to calculate it. Now total height is 100. So I will do 100 minus 20. You know, it's a triangular part there and angle 45. So I want to get the height and the length. So 100 minus 20 give me 80. Then, but we have this little part there, which is 12. So if I minus 80 from 12 from 80, that's 68, right? So that means the height is 68. The length also will be 68 there. 68 by 68. Why is it 68 and 68? Isosceles triangle. Okay, so I have an angle 45 there. So that means isosceles. The two sides will be equal. So meaning that when it's 68 now, I divide it by 2, that means I'm using what? 34. If I check with my ruler, from this point of 0.6 to this other point of intersection up there, it will give me 3.4. And that's accurate. Next, I take 3.4 for the other points. I hope you get what I'm doing there. So trying to get the line, then I join the 2 points as fence line at first. Then I continue to the next part. Now I'm having the lower part, so I join some thick lines that are necessary for the figure as I take it further. Now in this question we are given an orthographic projection, then we have to get it in isometric. So converting orthographic to isometric means, first of all, I'm going to develop a sketch of what the diagram is all about. So it's the sketch that will now help me to understand what I'm about to draw. But now this part is not entirely to the end. It will be as a curve there. So then I also join this little part, but not entirely down, just a little. Later we get the actual dimension. Now, total length from here to the midpoint of the circle is 102. Divided by 2, that's 51. So 102, I can't take it now because I'm scaling down. So that's 51. So that's 5.1 centimeter. So from each of these points, I'll take 5.1 from here, upward. And from the other points too, I will do the same and take 5.1 also. 5.1, 5.1, make sure the dimension is correct. Next, I place my ruler still on the construction line so that I can use my set square to intersect them. My ruler on the construction line, my set square on it, then I use it to intersect the 2 points. Now, where this line, we have the line there. Now, the midpoint of the circle has to be at the center. Now, the center of 100 here, that's center of 15, that's 25. So I mark 2.5. Then I mark 2.5 from here also. We said it's 100 divided by 2, that's 50. Then 50 divided by 2, that's 25. So 25, 2.5 is the radius there. So my ruler and my set square, I get the other line. Now between these two lines, that's the midpoint for the circle. But now we are not drawing a circle, we are drawing an isocircle. We are drawing an isometric circle. Now, how are we going to get this done? Now, the radius of the bigger one is 50. We've scaled it down, that's 25. So if you check there, it's 2.5 up, all this one at 2.5. This other one will also be 2.5. So left, right, up, down is 2.5. Now from this 2.5 I marked down there, I need to get a fence line across so that this can be my square. Yes, this will be my square for 15. Now, firstly, join the longest diagonal. That's the first step. Now, since I'm getting like a half of it, so I join the shorter diagonal to the two opposite midpoints, which you can see from the diagram there, the midpoint of the two opposite sides. Then I take my compass. This last line I draw, that will be the radius. It will intersect the other points that I have there. So with my compass, with the points of the shorter diagonal with the midpoints, I get my arc. But I didn't need to get the other one because I don't need that lower part. I only need it now to cover the down part. So I take the shorter radius, where the longer diagonal meets the shorter diagonal. That's the smaller the radius there. And that's the center for the points. I get my arc to intersect the two edges there. So which means now I can join this together and join the upper parts also together. Now, as we continue, I need to get a curve down there. So how do I do that? The depth down here is 1, right? So the mid that I get this smaller arc, where the two intersection of the shorter and the longer diagonal meets. So I'm going to take 1 centimeter downwards from there. I firstly get with my set square, then now I've gotten the point. With the same radius now that I use for that small arc, I will use the same thing now for this lower arc here. That's what I will have. Now I will now get a line tangential to the two. So I have to adjust that place well so that they intersect and doesn't exceed what it's supposed to be. So that's how we get an isocircle. That's how we get an isocircle. So a circle is different from an isocircle. If it's in a plane form, you draw it as a circle. But now it's in isometric. So this is the procedure. Join the longer diagonal, shorter diagonal to the two midpoints, then you continue. Now I will need to get the inner one now. The radius, the diameter is 15 divided by 2 already, that's 25. Now that means the radius of 25 there is what? 12.5. 12.5 is in mm. In millimeters will be what? 1.25. So I'm making use of 1.25. First of all, I divided by 2. Diameter divided by 2, that's the radius, which is what? 25. Then divided by 2 again, because I'm scaling down. Now that's 12.5. So then I take 1.25 on this line. How do I get 1.25 centimeter? Between 1.2 and 1.3, the space in between. So now having these 4 points, 1, 2, 3, and 4. So I put my ruler, then my set square 2. So I will get left and right isoplane from these 4 points. This one will be right isoplane, then the other 2 points, left isoplane. So that's in between, as you can see there, I have another rectangle, another square rather, in between. Now I make these lines to be thick so that you can easily see them, but it's not supposed to be as thick as this. Now join the longer diagonal, that's the first step for the inner one now. Then the shorter diagonal to the midpoints of the 2 opposite sides. That's what is done there, which you can see. Now I take the radius now, shorter diagonal with the midpoints. That will be my radius for the circle. Then the other point of the shorter diagonal, another one, to get the other lower parts. Is still the same procedure. Now the longer diagonal and the shorter diagonal, where they intersect, then to the edge of that curve there, I'll join it from that point to the other points. As you can see, I'll join it from that point up to the other point down. So this process will give me my isocircle. Then at the right hand side also, shorter and longer diagonal where they meet, I also join that part too. So this process gives me my isocircle, my isometric circle. So I'll take out the lines that are not really necessary. Then I continue to the next part of the construction. But now, if you view this diagram from up, something is still missing. It means we'll still be seeing a curve at this last circular part that we just did. So we're going to take the procedures next, but it will not be much. It's just taking some points and for us to get the curve. So that's what we are going to do next from here. So then we put all the dimensions that are needed, the total height, total length, and also the diameter. But that doesn't end the diagram. We need to indicate a circular part from the hollow part here. Now, the point that we take our first arc, that's the smaller part there, the smaller diagonal, that V shape there. So we take vertical line downwards. Then we extend down of 1 centimeter because the depth of that upper part there is 1 centimeter. So with the same radius we took to get the upper arc, so that same radius is what we are going to replicate. Then we put it at the points of 10 centimeter that we've gotten 1 centimeter. So that point also gives us the second radius, the second arc. So that's all for this diagram.